Hey everyone, I'm incredibly excited to be here today talking to you about building event-driven serverless applications using native service integrations and .NET 6. And what I mean by native service integrations is that we're actually going to build an application that doesn't have a single line of code running in production. We're going to do that using .NET and the AWS Cloud Development Kit. Yes, for the next 50 minutes or so, we are going lambda-less. I'd like you all to imagine a time when you've had to debug or fix a really edge case bug running in production. It was likely that that bug was introduced by a change someone made to a line of code. The code that doesn't change is almost always the most stable. Until, of course, at some point in 5 years' time when you need to modernise that code and actually nobody understands how it works. But fundamentally, any code that we write opens up the possibility for issues. We as humans are fallible, we make mistakes. I can't even begin to count the amount of times I've spent hours trying to debug an issue to realise it was a greater than symbol instead of a less than symbol. Like, we've all been there. The cloud started to abstract away a certain type of bug, one around the underlying hardware and the infrastructure. And as we move further away from the hardware and towards a more serverless architecture, more and more of these operational bugs start to move away because AWS start to take on more of that operational responsibility. I think we can all celebrate that. Now we're in a place where you can deploy applications in which all you need to care about is your business logic, your custom code, solving the hard, complex problems that probably made a lot of us want to be developers in the first place. Serverless enabled that. And some other advances in technology and services have enabled us to write even less code. Things like translation, text-to-speech, video transcription. All of these things that might once have set your business apart are now just an API call away. And in my mind, that starts to make the code that's doing these things more of a liability and a burden. It's code that needs to be managed, kept secure, packages that need to be kept up to date, all for what is likely to be 2 or 3 lines of code that just make an API call. Things I'd refer to as glue. It's not adding any value to your customers. It's just sticking 2 parts of your system together, doing something that isn't really differentiating you as a business. So imagine if we could take serverless architectures one step further. Imagine a world in which you can build and deploy entire applications without running a single line of code in production. Over the next 45 minutes or so, we're going to look at how you can build event-driven applications with .NET and the AWS Cloud Development Kit, like I said, without actually having any code running in production. So who am I? I'm James Eastham. I'm a professional services consultant at Amazon Web Services. By day, I'm helping AWS's customers build and deploy applications on AWS. But by night, I'm a lover of all things .NET and serverless. That's where my interest is, helping people build and deploy really resilient and really secure applications using .NET and AWS serverless services. That's when I'm not out running or looking after my 3-year-old Labrador. So what are the next 45 minutes going to look like? Well, I thought I'd start with a demonstration of the application that we're going to build. That way we can start from there and work backwards, and we're all developers. We like seeing interesting things happening. And then I'm going to go through the why, the what and the how. I think it's important to take a step back at times like this and understand why we're doing these things. Why do we need event-driven architectures? Why are we looking at low-code, no-code solutions? We'll then start to look at what are the components that make up this architecture. And then we'll actually get into some code and we'll actually look at the .NET code that makes all of this happen. But as promised, we'll start with a demo. And to set the scene first, I want you all to imagine that you have a new requirement in your business. And that requirement is for a new API within your organization that's going to collect reviews for your company's product or service. It needs to accept reviews in any language, translate them languages to English, and then perform some kind of sentiment analysis on them reviews to route any negative reviews to customer service and just detect how many kind of good or bad reviews we're getting. It needs to be auditable. We need to understand what's going on in the system, and it also needs to support queuing any negative reviews up for a customer service agent to look at. And we then also want to send emails back to reviewers to thank them for a positive review, or just let them know about the next steps for a negative review. So architecturally, this is what the system looks like behind the scenes. So we've got 5 completely independent services that don't communicate with each other at all. All of the communication from service to surface is via events. It's completely decoupled. We've got a service to actually receive API requests into our front end, and this is a more traditional REST-based API. We've got a sentiment and analysis and translation service that actually performs the translation from non-English and also detecting the sentiment. We've got our event audit service to actually start to audit the events that are flowing around the system. We've got our customer contact service, which is the service that's actually going to queue up any negative reviews and handle that customer service workflow. And then finally, we've got our notification service, which will actually send emails back to our customers. So let's go and see that in action. Okay, so here's the quite rudimentary interface we're going to be working with. Full disclosure, I am not a front-end developer or designer, so excuse the terrible design going on. So what I can do is I can now submit a new review through the user interface, and I'm going to say this demo is awesome. When I submit that review, you see I get back my review identifier. Now, this backend hasn't been pre-warmed. You saw there was quite a low latency there. There's no cold starts, there's no warming up phase. That step functions is just ready to accept my requests. If I now query my event audit database directly, I can see there's 3 events for that review. There's the fact that my new review was created, there was then a positive review identified, and an email sent. If I was to go off and look at my inbox now, I would see that there is a new email saying thank you. If I now submit a second review now, and this time I'm going to submit a negative review. So if I do that, and I'm actually going to submit this in Spanish. So I'm going to say this is terrible. Submit that. Again, you see the consistent latency with that response because we're just invoking a step function workflow. If I query that new review identifier, you see I've now got negative events. So that's been identified as a negative review. And you see that's happening very quickly. That review's going through the whole process of translation, sentiment analysis, the events being passed around incredibly quickly. I'm just going to grab a copy of that review ID now, and I'm going to go off and look at this customer service agent interface. And with this interface, I can just claim a record off the queue. If I do that, I will get a description of what that review was. So you see I've got the review from my email address, and also I've got the English version of this review. Because our customer service agents are based in the UK, so they need to be able to speak English. I can then say I'm the customer service agent who's going to claim this and actually submit my claim of that review. And this might then go on and trigger a whole raft of other business processes. If I come back to my review page now and query the review results again, you see I've now got 2 additional events. One that my customer service case was claimed, and the other that an email was sent back to the reviewer to say that somebody is working on their case. And there was consistent latencies all around. You saw that. This is all really low latency, really fast, really resilient, and all with native service integrations. Let's get back to the presentation. Okay, so now that we've seen how this application is actually going to work, like I said, we'll just take a step back for a moment and look at why we want to do this. So we've already discussed some of the challenges that come with any code we write and maintaining that code. It opens up the potential for bugs. But I just wanted to take a few minutes to discuss event-driven architecture and the benefits of building out your systems in a more event-driven way. And to do that, I'm going to take an even bigger step back. And I actually want to start with a little bit of human biology. So it's estimated that our brains process 11 billion bits of information per second. That is a lot of data. And when you think about it, our brains are just giant event consumers. They're constantly taking in events and making decisions based on the world around us. All our senses are just sending events to our brain, and our brain is reacting to them events and doing things as and when it needs to. If I touch something with my fingers will send a touched event to my brain. And if that event includes something about the temperature of the thing I've touched, let's say I touch my stove, my brain's going to react and then trigger my muscles to move my body away. But if that thing I touched wasn't hot, there was no reason to react, my body wouldn't. It's incredibly efficient in that respect. It only reacts to things that it's interested in. And at a slightly higher level, as humans, we rationalise about the world in a very structured, event-driven way. This event happened that caused this event to happen, that then caused us to go and make this decision. We like assigning cause and effect to things. If we start to now think about that from our application perspective, our system perspective, if we make events first-class citizens in our architectures, fundamentally we're aligning with how we as humans rationalise about the world. And that makes our systems incredibly easy to rationalise about because we're aligning to what is, in essence, the human way of navigating the world around us. Let's take a small step back forward now towards the technical. The fallacies of distributed computing are a set of fallacies proposed by Peter Dush and some of his colleagues at Sun Microsystems. And what these fallacies describe are some false assumptions that programmers make who are new to distributed computing. I've highlighted 5 of these in bold, and the observant amongst you will probably have noticed that these are all the ones related to the network. For any of us who've worked in technology for any period of time will know that the network is unreliable. There's latency on the network, it's not secure. And as we start to move to smaller and smaller microservices and bigger levels of decomposition, these network-based fallacies become all the more important. You can even consider any application running on the cloud by its very nature a distributed application. These network-based fallacies become so important once you're using microservices, and it's absolutely vital to design an architecture that minimises the latency and gives your customers a great experience, but also handling the realities of these fallacies. And when it comes down to it, it's all around coupling. Coupling is the most important thing to consider when you're thinking about distributed systems. When you're integrating 2 services together, however you choose to do that, you are introducing some element of coupling. The most traditional way to do that is over a synchronous REST or RPC based request response. Service A makes a call to service B, and service A will wait and it will block until service B responds. When service B responds, service A will continue doing its work. And when you've got a small number of services, this kind of coupling isn't hugely problematic. If you've got 5, 6, 10 services, you can kind of understand the different connections and the different failure paths that are going on within your system. But once you've got hundreds of services and tens, if not hundreds of different teams running them services, that can become really problematic. Cascading failures start to become an issue. If service B was to go offline, maybe there's 10, 20, 30 services relying on service B to do some work. And if that is synchronous request response based, that can then start to cause other parts of our system to fail, and fail unexpectedly. Even if service B is online, the network could go offline. There's a lot of different things that could cause our system to go down. And that's where event-driven architectures start to become really powerful. When we start to think asynchronously, it allows us to really reduce the coupling in our system. And I love this quote from Gregor Hope from his book Enterprise Integration Patterns. And how I understand this quote is around how you as a team manage your coupling to different endpoints. So if you are a team maybe running 4-5 services in a much larger microservices based ecosystem, the 4 or 5 services you own, coupling them together more tightly, maybe over RPC or synchronous based communication, is less risky because you own all them services. You own the SLAs, the release cycles, the schemas of the endpoints. So coupling them together slightly more tightly may not be as big of a risk. Whereas if you're integrating with one of the many other teams within your organization, you want to reduce that coupling as much as possible to not be reliant on another team's release schedule or another team's schema management. And that's where event-driven architectures really start to shine. So we've talked a lot so far about applications running without a single line of code in production. I think I've said that line 4 or 5 times now, and I imagine some of you are thinking this is the start of the robots taking over and running us all out of jobs. So are these low-code, no-code solutions the future, and is this the end of development as we know it? And to answer that question, I want to briefly talk about domain-driven design. In domain-driven design, there's a concept of subdomains, of which there are 3. There's the core domain, the supporting subdomains, and the generic subdomains. The core domain is your moneymaker. This is your unique selling point, the things that make customers love you. This is where you're writing the code to solve the hard problem that's making your customers happy. As much effort as possible should be focused here. Supporting subdomains are parts of your application that are required to make your core domain work. Without them, your application would not function, but they aren't vital to your business. In our sample application, these will be the translation and sentiment analysis services. We need them for our core domain to work, but they aren't differentiating us from any other organization. And then generic subdomains are typically ready-made solutions, parts of your application that don't really differentiate you at all. Sending emails is a good example. All organizations need to send emails. It's completely generic. Now, there may well be development work required for setting up the supporting and generic subdomains, but wherever possible, we want to focus our time and effort on the core domain. As developers, we want to be spending our time solving the hard, complex problems that will delight customers. I'm sure that's why a lot of us started doing development in the first place, and I see low-code, no-code solutions as an enabler for developers, not for something that's going to take over our jobs. It enables us as developers to focus on the problems that matter, to focus on our core domain, and abstract some of that operational responsibility and management of our supporting and generic subdomains onto AWS and onto cloud providers. Okay, so what do we actually need to build this? What services are we going to use to actually compose this event-driven lambda-less architecture? And there's 2 pretty fundamental services to make this work. And I just want to level set on them 2 services before we actually get into some application code. And the first of which is AWS Step Functions. So Step Functions is, in its rawest form, just a workflow engine. It allows you to define steps, and data moves from steps to step. Step functions carry an element of state along with it throughout a given execution of a workflow. When you execute a step function, you can pass in some input, and then that input will be passed from step to step throughout the workflow. It might get manipulated or it might change, but there is an element of persistent state. Step functions is powerful because it allows you to build reusable components that can be orchestrated together into a single business workflow. If your workflow changes over time, you can just resequence or swap out different parts of your workflow as your business needs develop. Step functions also integrate with a wide range of other AWS services, including APIs, event buses, which allow you to invoke your step function without a single line of code. And we'll talk more about the integrations in just a little while. When you define a workflow with step functions, that's built using Amazon States Language, or ASL. ASL can be written in either JSON or YAML, and it can be a little bit tricky to get your head around. I know when I first came to step functions, understanding the syntax of ASL was one of the biggest challenges that I found. But as of 2021, as of September 2021 should I say, that was changed by the Workflow Studio. And this is one of two features that quickly made step functions one of my favourite AWS services. Workflow Studio is a drag and drop designer for building out your workflows. It allows you to build your workflow and then export it to ASL, and then you can put that ASL in source control or CI/CD. You can then also import your ASL back into Workflow Studio, make any changes and export it again. And that's actually my go-to workflow for building step functions. It's also incredibly powerful because as developers, we can now sit down with business domain experts and actually build a workflow together. So your business expert doesn't need to know what Lambda is or what EventBridge is, but they can sit and look at a flow diagram and actually visualize how data is going to flow through the system. And that just enables so much more efficiency, both from a business and a developer perspective. You can sit down next to each other and technically build out that workflow together. The other way you can build step functions is using the Cloud Development Kit, or the AWS CDK. And that's where we're going to spend most of our time today, building out the step functions using .NET. For anyone who hasn't heard of the AWS CDK, it allows you to define your infrastructure in a programming language of your choice. And that's really enabling for developers because you don't need to go and learn CloudFormation or Terraform. You can just define your AWS infrastructure using .NET and then deploy that. And what actually happens behind the scenes when you deploy something with CDK is it synthesizes your .NET code into a CloudFormation template and then deploys that CloudFormation template. It's incredibly powerful, and we'll see more of that when we get into the code samples. The final part of step functions that I just want to touch on is step functions' intrinsic functions. So intrinsic functions are functions that are built into step functions that allow you to do interesting and quite complex things actually without the need for any custom code. And there was actually 15 new intrinsic functions released last week. So you can now do things like check the contents of your arrays, base 64 encode and decode strings, generate hashes, random numbers, and even unique identifiers. And that is actually one of my favourite one of the new intrinsic functions is the states.uuid. So what that means is you can now generate unique identifiers within your step functions workflows without the need to call out to a Lambda for the sake of just generating a GUID. This isn't an exhaustive list, but I've highlighted a few of what I think are the most useful. And we'll see the states.uuid in action when we get into our code samples. The second service that makes all of this possible is Amazon EventBridge. EventBridge is AWS's event bus service. It allows the decoupling of producers and consumers and helps you to really quickly start to build out an event-driven architecture. EventBridge makes it really easy to connect applications. You can ingest, filter, transform and deliver events without writing any custom code. EventBridge automatically scales based on the number of events ingested, and you only pay for the number of events published. EventBridge is completely serverless, so it has that built-in availability and fault tolerance that means you don't need to worry about the operations of EventBridge. That's on AWS. EventBridge is also directly integrated with over 130 event sources. Internal AWS services like S3 and EC2 and RDS are always publishing events to the default event bus that will exist in all of your AWS accounts right now. You can also publish events from your applications or publish custom events into EventBridge. And it also integrates with a wide range of SaaS providers, so companies like Datadog and Zendesk. And you can actually set up an integration where them organisations can publish events directly into your AWS account for you to then react to. So that's the producer side. At the consumer side, you define rules, and you use rules to match an incoming event for a given event bus and then route that event to a target. And a single rule can actually route to multiple different targets, all of which are processed in parallel. A rule can also customize an event before it's sent to the target by maybe manipulating the contents in some way or overwriting a field with a constant. You can also have multiple rules that match on the same event. So you can have one central event bus for your entire organisation, and your different services and different teams can all define their own rules. From a target perspective, EventBridge integrates with other AWS services like Lambda and SNS, and you can also make HTTP API calls directly from EventBridge. It also integrates directly with step functions, and that is the integration that we're going to see a lot of today. You can trigger a step function workflow directly from EventBridge. And the final really cool feature of EventBridge that I just want to touch on is schema registry. So when you enable schema discovery on a given EventBridge, EventBridge will start to analyze the events that are flowing through your system and actually generate a list of all of the schemas of your events. Now, if you think from a development perspective, if you're now coming to build a new feature in your application, you've got this one single pane view of all the events that are already flowing through your system. So you can then look at that and think, right, what event do I want to hook into to actually trigger my new feature, my new application, order created event, new review received event. You can hook into these things and really quickly add new features and new services without actually integrating or touching any of the existing services that are already running. So it's an incredibly powerful feature when it comes to adding new features and building out functionality. Okay, so how exactly are we going to do this? Yep, it's time to look at some code. So as much as we are starting to think asynchronously as a default now, with our systems at some point, somewhere, it's likely we're going to need some kind of synchronous point-to-point REST API. And we do in our system. We need a way to allow a client, and that might be a web app or a mobile app. In this instance, we've built a web app, to interface with our review analysis service. To do that, however, we're going to implement what we'd call a storage-first API. And what I mean by a storage-first API is that our synchronous API doesn't actually perform any business logic. It simply receives a request, stores that durably, and then notifies any interested consumers that a new request has been received. And then it returns to the caller. And this gives us a really consistent latency, a consistent performance, but it also allows us to start to apply back pressure. Maybe we can just start storing our HTTP requests as they come in, but maybe not react to them straight away. Maybe if we want to replay some production load, maybe for some performance testing or some system testing, we have got a list of actual HTTP requests that came in. So it's a really powerful way to start building out your APIs. And to do that, to build the front door of our application, we're going to do that using a combination of API Gateway and Step Functions Express workflows. Step Functions Express workflows are one of two types of workflows in Step Functions, and they're designed for high volume workflows that are going to complete in less than 5 minutes or so. Think IoT data ingestion or mobile data ingestion, streaming data, things like that. One of the beauties of using Express workflows is that it integrates directly with API Gateway. And what that means is that API Gateway can directly invoke a step function, and it will pass the contents of the HTTP request into that step function as an input. API Gateway will then wait for the step function workflow to complete or maybe fail, and the results of your step function workflow will be passed back to API Gateway and then back to our caller. So in this example, we're receiving a new request into API Gateway, and that then triggers our step function. Our step function workflow is going to generate a unique identifier using the UUID intrinsic function, and then it's going to persist that data into DynamoDB. Using that newly generated UUID, it's going to publish a new review event to EventBridge. And then finally, we just do some formatting to generate a friendly response to return back to our API caller. So let's have a look at that in our application. So here we are in Visual Studio now, and just to quickly talk through how the CDK works and how this project's set up, we've got at the top level this event-driven CDK stack. And what I'm actually doing just for the ease of deployment is deploying our 5 separate services in one single deploy command. This could quite obviously be separated across 5 separate CDK projects because of how decoupled it is. So at the top level, we've got this event-driven CDK stack. And you see we've got a few resources here. So we've got a shared resources object, we've got our front-end API, we've got the review analysis, the event audit, the notification service, and the customer contact service. So you can already kind of see this is a really logical way to define your infrastructure as a developer. If I want to go and look at the infrastructure for my front-end API service, it's just a C# object. It's a really powerful way to build out your infrastructure. So before we get into the front-end service, I'll just have a quick look at these shared resources, because as part of this shared resource, this is where we're deploying one central event bridge. And you can see here I'm just creating an event bus, and I'm creating objects as I would create any object in C#. I give that event bus a name of central event bus, and then I'm just enabling a schema discovery so we can have a look at that. To make things a bit easier within this project, I then have a static object just so I can pass this event bus object around to be able to add rules to it. So that's what's in our shared resources. But yeah, now let's have a look at our front-end API service. That is what we're here to see. So if I go into the front-end API service now, there's a few things going on in here. So the first is that we're building a DynamoDB table. If you remember, we want to store our requests. This is a storage first API, so we need a DynamoDB table to store them in. And then we've also then starting to build out our workflow. Now when you build workflows, step functions in CDK, the syntax can get a little bit complicated. So what I always recommend people to do is abstract some of the complexity of the step functions workflow definition behind some logically named classes and methods. So you see here, this is we can read this step function as humans and understand what this state machine is doing. We're generating a case ID, we're storing the API data, and with that we pass in our DynamoDB table. We publish a new event, and you see there we're passing in our central event bridge. And then we're actually formatting this HTTP response. Now if I go into each of these individual steps now, this is where we're hiding away some of the complexity. So you see for our case ID generation, this is actually quite straightforward. This is using what's called a pass state in step functions. And a pass state just allows you to perform data manipulation and change the format of things, or you can just use it as a placeholder that does nothing. So you see we've got our payload that gets passed through our entire input, and then we're also adding this additional property of UUID, and we're generating that using that intrinsic function that I talked about earlier, which is states.uuid. When you're using any kind of intrinsic functions in step functions in CDK, you need to make sure you put this $sign after your property name, and that tells step functions that you actually want to run a function, not just use the word UUID and with a value of states.uuid. When we get on to storing our API data, things start to get a little bit more complicated because we're actually calling DynamoDB now. And the integration with DynamoDB is one of the optimized integrations, which means we actually have an object in the step functions part of the CDK library that allows us to do a DynamoDB put item call. So you see here we're making a call to our API table that we passed into the method, and then we're actually building out our DynamoDB item. Now this, I'm not going to deep dive into DynamoDB right here, but DynamoDB fundamentally is a key value store. It allows you to define a partition key, and our partition key in this instance is coming from our step function state. We're using that UUID property that we generated, and then we're just storing a bunch of data in a map attribute, which just stores some of our request contents, the review ID, which again comes from the UUID, the email address that submitted the review, and then the contents of the review. That's stored straight away. That's the second step. We're then publishing our API request event, and again, this is one of the optimized integrations. So we actually have an object in our step functions part of our CDK library that allows us to do the EventBridge put events API call. And we build out the detail of our event, so we're adding the content, the detail, the payload of our event. We're setting the type to be a new review event, and then we're setting the source of this, and the source is our API, of course. And then the event bus is that event bus that we're going to publish to, that shared one that we created in our shared resources. And then again, just to finish off, we've got another pass state just to format that response that goes back to our API in a friendly way. So the API response we'll receive will look exactly like this. We'll have 4 properties in the JSON, 2 of which come from the UUID, and then we've got the email address and the review contents. One of the other really powerful things about CDK is that this workflow, this step function now obviously needs permissions to write to our DynamoDB table. So you see what I can do here from my API table object. So this is a DynamoDB table. I have some really helpful methods on that table around granting access. So I can say grant write data to my state machine. And then that allows me to really easily not need to worry about the IAM actions and the IAM permissions. Almost all of the objects in the CDK library have these similar grant methods, so you can grant permissions to a given resource. The other really helpful thing with CDK is the constructs. So you see here, when I actually build my API, I'm not building an API gateway of a certain type. I've actually got an object in the CDK library called a step functions REST API. And all I need to do to define this is give my step functions API a name, and then I just pass in my state machine. And what CDK will do at the point when I synthesize the CloudFormation template will actually generate all the CloudFormation required to set up this integration. And if you've ever done this manually, it is actually quite an involved process. But I'm setting up an API here backed by step function using 3-4 lines of code. And then I'm finally just outputting my API endpoint so that when I deploy this, I get my API endpoint in my terminal. So that's how we build an API with the CDK. And you can see we've got maybe 50 lines of code there, and we've built out a full API that does unique ID generation, stores the request, publishes events, and then actually even builds the API itself. Now you can see, I hope this is helping you see that with .NET and the CDK, you can build out incredibly powerful applications just using native integrations. Let's get back to the deck. Okay, so we've now got reviews coming into our system. Awesome. But now we want to start integrating with other things. So what we're going to look at now is how you can integrate with almost anything using AWS step functions. So with the integrations available in step functions, historically there was what was called optimized integrations, and they're integrations that the step functions team had built directly with other AWS services, and there was about 17. Things like EventBridge, DynamoDB, Lambda, they are all optimized integrations. But as of last year, the step functions team announced the AWS SDK integrations. And this is the second feature of step functions that has made it my favorite AWS service. And what the SDK integrations allow you to do is call over 200 AWS services, which is over 10,000 API actions directly from within your step function. No Lambda glue required. And this opens up a whole realm of different possibilities of things that you can do in step functions. And we're going to see some of them now. So with our translation and sentiment analysis workflow, this step functions workflow is triggered directly from EventBridge. So there's a rule defined on EventBridge listening for our new review events, and the target of that is our sentiment analysis. This workflow is going to use some of the AWS services like Comprehend and Translate to make API calls directly to these services. So we're going to detect the language of the review that comes in. If it's not English, we're going to then run translation to translate that from whatever the current language is to English. And then we're going to run sentiment analysis on the English version of that review. Based on the results of that sentiment analysis, we're then going to publish either a positive or a negative review event that other consumers can then react to. And this also applies for our notification service. So our notification service is listening for them positive and negative review events. And based on the type of event it receives, it's going to send out an email. And because we can integrate directly with almost any AWS service, that also includes the simple email service, or SES. So we can now send emails directly from within our step functions workflow. And if you think with this notification service, if we started to receive new types of events, we could just add additional rules to this service, and we've got now one place where all of our emails are defined. The HTML, the actual body, the to, the from, all of that. It's really powerful. So let's now have a look at how you can define and build native service integrations using .NET and the CDK. Okay, so we're now going to have a look at how we can build the integrations using the AWS SDK in the CDK. And to do that, we'll look at our review analysis service. So the first thing I actually want to call out in this review analysis service is actually this bottom section here. So you remember we defined that central event bus in our shared resources. Well, we're now adding a rule to that central event bus. And that rule, from the source of that rule, is our API, of course. And the type of event is a new review event. And then we're also passing in the target, and the target is our state machine. If I go and look at this add rule method, this creates a new rule object. Again, this is just an object that comes for the EventBridge part of the CDK. It defines the bus we want to create that rule on, and then it passes in the rule names and the patterns and the targets that we want to use. And you see we've got a step function state machine target here, where we're passing in our workflow. Okay, so if we go back to the actual workflow itself now, and this service is a little bit different to the front-end service in that we only have a workflow, we only have a step function. And the step function is defined in two parts. We've got the first part, which is a module to actually just do the sentiment analysis. So again, we're abstracting away that more complex part of defining a step function and hiding that behind an easy to read method. So the first thing we're going to do is analyze the sentiment. And then next, we have a choice. When the sentiment result is positive, we want to then publish a positive review event to our event bus. And then when the sentiment score is negative, we also want to publish a negative event. And if it's not positive or negative, then we're just going to ignore it for the moment. So that's a module of our workflow. We've then got the actual workflow itself here. And the first thing we're going to do in the workflow is detect the language. And we do some formatting on the results, and then we're going to actually check for perform a choice on if it's non-English. So when our condition of when the dominant language property in our state is not English, then we actually want to run the step to translate the non-English. We want to add that translation, and then we're going to run that module we defined earlier. If this condition is not true and it is an English review, we're going to skip straight through to that analyze sentiment module. So let's start to dive in and look at some of this step functions code now. So as well as the native integrations we had in the last front-end API part where we were calling Dynamo put item and EventBridge put events, within the step functions part of the CDK, we also have this call AWS service object. And this allows us to define any action on any AWS service, and we just pass in a dictionary of the parameters that are required. So in this instance, to do our sentiment analysis, we're calling comprehend. We're calling the detect sentiment method on comprehend. And then we're passing in some parameters, and these are the same parameters you would use if you were using the AWS CDK. So we pass in a language code of English, and we want to pass in the text of our review context. We can also define specific IAM resources, so in this case it's all resources because we're calling comprehend, and we can also pass in a path, a result path, where we want the results to get sent to. The same applies for when we do the non-English translation, we're calling translate. When we're doing the language detection, again we're calling comprehend. And then the other parts of this workflow are pretty similar. We've got EventBridge publishing events. We have a past state just to do some manipulation of our state. The other really cool thing about using this call AWS service object is that when you compile your workflow and generate the cloud formation, CDK will automatically add the required permissions to your step function. And that's why we've got this IAM resources section here, because when this CloudFormation template gets generated, that will actually include permissions for our workflow to call detect sentiment on the comprehend API and for any resource. That's automatically done for you. All you're doing is defining the AWS service that you want to call. If we go and look at our notification service now very quickly, this is actually very similar. So in this instance, we actually need to define the content of the email that we want to send. So in the workflow steps, we've just got a single workflow step of send email. And again, we're using this call AWS service object. In this instance, we're calling SES and send email. And the send email API is actually a bit more complicated than maybe some of the comprehend ones. So you can see these dictionaries get quite a few layers deep. And then we've got our event publishing. Now you can imagine if I had to have this same big set of 50 lines of code repeated over and over again in here, that would actually make this look really complicated. But instead, I'm just saying when the string of the input, when the type of input is a customer service case claimed, then I want to send an email, and I can define the subject and the body. When the string equals positive review, then obviously I'll send a positive review email. And when it's negative, I'll send a negative review email. But what you can see is all of these instances where I'm just calling AWS services, all I need to understand is the service and the action name and the parameters that need to go into that. And remember, I can integrate with almost any AWS service now using this integration. Let's get back to the deck. Okay, so now I'm imagining that your brains are just imagining the possibilities of just what you could do now with these native service integrations. But before I let you go run off and start playing with this, there's one more pattern in step functions that I just want to talk about quickly because it's a really powerful one, and that's the callback pattern. And what the callback pattern allows you to do is to make a request from within step functions and then pause your workflow until the point in the future where step functions receives either a success or a failure, which will then allow your workflow to continue. So we're waiting for an external service to call back. Where we use that in our application is in the customer contact service. So when we receive a negative review event, that triggers a workflow that simply just puts a record into an SQS queue. And when it does that as part of the message that is put into SQS, it includes a task token. And that token is uniquely identifiable to our execution of our workflow. As you saw in our front-end demonstration, the front end can then go and claim a new review from the queue, and that will pull the record out of SQS. And then when we actually confirmed who we were in the front end, that both deleted the message from SQS and sent a message back to the step functions API to say this task token has been successful. At that point, our workflow will then continue. It's worth just pointing out that not all of the integrations support the wait for callback pattern, but SQS is one that does. Okay, so that's covered all of the different components of our application and how you can build them using the CDK and .NET. But what's next? What can you do now when you leave this session to go and start building things? Well, the first thing I'd encourage you to do is go and check out the Serverless Workflows collection. And this is a page on the Serverless Land website. If you haven't heard of Serverless Land, that's a website managed by the AWS Developer Advocacy Team, and it includes, amongst many other things, a whole section that contains sample workflows built with step functions. You can also, from within the web page, deploy these workflows directly into your AWS account to play with. The second thing I'd say is to start thinking about your architectures as composable, reactive building blocks. With the seamless integration between EventBridge and step functions, you can trigger complex business workflows without any integration code. When you consider that the building blocks you have available to you in these workflows include almost any AWS service, this becomes really powerful. And let's not forget about Lambda. The title of this talk was intended to be a little bit tongue-in-cheek. Lambda absolutely still has a place in this low-code, no-code world, but use Lambda to focus on your core domain. As developers, you can then focus your mind on the hard business problem you're trying to solve that will delight your customers. And run that in Lambda, because inevitably in your business there's going to be parts that require some custom application code. But everything else, the supporting things, the generic things, let AWS shoulder some of that responsibility. And my final piece of advice, imagine the possibilities that are now available to you and go play. Thanks for listening.